Okay, ready? This is actually going to take us all the way back to the beginning of the year.
Limits?
Limits.
What's a limit?
It goes away. It goes away.
It's over winter break.
Number one.
Okay, so we got this guy. His name is L'Hôpital, which translates into the hospital. And this is his rule. I don't know why he didn't call it a law, like most mathematicians, but it's a rule. And it allows us to solve limits that we haven't been able to solve before. So you recall, way back when we took a limit, if we got 0 in the denominator, that was a problem. So then we did a bunch of different things. We plugged and chugged first, like you always should. We simplified algebraically or algebraically manipulated. We plugged and chugged again. If that didn't work, we tried something else. Or at some point we just say, we can't do it. So L'Hôpital realized one small thing. If you get something called an indeterminate form, that's a big word. Indeterminate. Yeah, there you go. Form. We're gonna talk about 2 of these indeterminate forms today. Then tomorrow we'll look at about 3 or 4 others. So we're gonna crawl before we run here. If you get one of those, there's a simple solution which will allow you to continue to take the limit. So the 2 intermediate, that word forms we're gonna look at today are 0 over 0 and infinity over infinity. So you plug and chug, like you always should for a limit, and you get 2 over 0. That's not an indeterminate form. That's 2 over 0. You handle that the way we handled it at the beginning of the year. But if you plug and chug and you get 0 over 0, now L'Hôpital's rule kicks in. And L'Hôpital realized something very simple. He said, if I get a 0 over 0, it doesn't work. But if I integrate the top and integrate the bottom and do it again, I'll get the same limit. Okay. The practicality of this is easy. I will write the actual theorem down here just so I can say I shared it with you. There's no numbers up? Oh, I guess there isn't yet.
On the prime,
Terrifying.
the 1. There's a number.
What is it?
No, infinity's not a number, it's a concept. So that actually doesn't have any numbers in it.
What about the ones on the primes?
Those are primes.
Okay, that looks great. Fantastic. What the hell does it mean? The application of L'Hôpital's is pretty easy. And you're probably asking yourself, why are we doing this now? Why didn't we do it when we were covering limits? Well, there's one simple answer to that question. When we were covering limits, we didn't know how to take derivatives. And notice, that's not a quotient rule. Don't make your life any more difficult than it has to be. That's just the derivative of the numerator over the derivative of the denominator. Pretty easy.
So how did you prove that they're equal? Their values are equal?
I don't know.
Slide.
I actually don't know the proof of L'Hôpital's rule off the top of my head. I could look it up. It's probably on the Google somewhere.
It's on the Google.
Yeah. So you could, if you got nothing to do later.
Yeah, probably.
Now that you're done stalking freshmen and you have your money.
No, they're not done. They're not done being stalked.
The hunt has not started. Okay. Oh yeah, we're starting right away with trig.
Oh, yeah.
Oh, shut up. Here's another problem. Now that we've done L'Hopital's, you're gonna think that every single limit problem is L'Hopital's. Okay? You're just gonna automatically see a limit with a rational function and start taking derivatives and it still follows the same rules from beginning of the year. Plug and chug first. Demonstrate that you know that it's an intermediate form first, then go and apply L'Hopital's rule. Question?
You mean indeterminate, right?
Yes, thank you.
Just making sure I was confused.
Doesn't work for this one, right?
I don't know, does it?
Zero result. Good.
What happens when you plug 0 in?
Zero.
What's the cosine of 0? 1 times 3 is plus -3 is
Zero.
0, and 2 times 0 is 0. So therefore we have 0 over 0. How do you demonstrate that you've done that? You do 0 over 0, check. Right. Look, I checked that it's indeterminate. Indeterminate. Intermediate.
Intermediate.
Interdispersed.
Catalyst.
Whatever the word is.
Intermediate.
Hey, that doesn't work. So now, since I have a check mark there, I can apply L'Hopital's. Still write the limit. Take the derivative of the top. Oh, I don't know. Patrick, what's the derivative of the numerator? It's been a while, I know.
Yeah.
Don't take him down the dark path.
U
Right.
plus C.
Right.
Plus C.
What's the derivative of cosine?
I'm blank. Yeah, negative sign.
Negative sign?
Yeah.
Yeah.
No. Yes.
Yeah.
Yes.
Yes. It's the opposite of the golf ball rule.
Negative sign?
Yes.
Good. Okay. So the derivative of 3 cosine is? Shh.
3 cosine would be just negative sign. No, 3 negative sign.
Derivative of 5x?
5.
Derivative of -3?
No.
Derivative of 2x?
2.
Well done.
Oh, yeah.
Not plus C,
No,
stop
not-
it.
That goes away.
That's on you. Yeah.
Evaluated from 0.
Because you know, some people are sitting there going, oh yeah, yeah, plus C. No, no.
Archimedes symbol from 0 to 10.
Plug and chug. What's the sign of 0? 0. 5 halves. Done.
5 F's doesn't equal 0.
Yes, sir.
Why do we have to do partial?
Because that's not what the hospital said. He said just take the derivative of the top, take the derivative of the bottom.
Can you do that?
It's not with the hospital.
Always.
So,
Yeah, I'm gonna find a way.
we never
I'm gonna find a way to make it easier.
No quotient rule here.
but when you're taking normal derivatives, can you do that?
You're talking about
Oh, so this isn't a real derivative?
correct.
Oh, it's special one?
It's
It's a special one,
It's a
correct.
derivative ratio.
So all the rule is just take the root top and bottom.
If it's indeterminate.
Okay.
That's the big if there. Oh yeah. Here we go.
Oh.
How do you know that number's right?
It goes away.
Yeah, that's what it's called.
It's a 2 for 1.
You know that like numbers right? That's 1 right plus 1 minus.
Because I trust L'Hopital.
Well, like,
He had it on his face.
like is that where it would be on the rep?
If you grabbed it, you'd see that that was.
It's a chain rule.
All right. What's e to the 0? 1. What's e to the -0? 1 plus 1 is
2.
minus 2 is
0.
hot diggity. The numerator is equal to 0. What's the cosine of 0? 1 minus 1 is?
0.
Check.
Check mark.
Don't forget the check mark.
Can
Oh, it might be.
It's the whole.
We're not messing around here. Olivia, help us out here. You got a Harvard sweatshirt on, you're very smart.
Two?
Is that Harvard?
No, it's University of Chicago.
Equally as impressive. The Harvard of the Midwest,
Okay.
if you ignore Harper. Does it help when you close one
I
eye?
don't know. Let me think.
Okay.
Isn't it? I don't know. Wait, no. Isn't it 3L and X? No, I don't know.
Okay, what do you got? What's the derivative of e to the 3x?
Isn't it 3
Me either.
She'll explain it.
It's e to the u and du over dx
Yeah.
We learned
Chain
that.
rule. Because remember, we're doing derivatives, so chain rule is legal now. Derivative of e to the anything is itself times the derivative of the exponent. Olivia, back to you. What's the derivative of e to the negative 3x? I don't know why I'm shouting at you. Olivia, what's the derivative of e to the negative 3x, please?
Negative 3e to the negative 3x.
Uh-huh. And the derivative of negative 2?
Nothing.
Derivative of 1?
Nothing.
Derivative of negative cosine 5x.
Sine x times 5.
Close. Sine 5x.
Why?
Derivative of cosine is negative sine of that thing
Oh, so it would be.
chained on the derivative of that.
Oh, so it would be like sine x times 5. So it would be sine 5x.
Correct.
Right?
Yeah.
Okay.
Good. Plug and chug.
Well, can you just turn the 3e to the 3x into a negative 1?
No.
Will you ever still?
I don't do anything. I just want to plug and chug.
Will you ever still get zero?
I'm sorry?
Will you ever still zero?
Plug and chug.
Wait, what's that little bit of there?
0 over 0 again?
Yeah.
Uh-oh.
Gotta do it again.
Why can't we just make it
Yeah, you throw a check mark on that one too.
Can you throw in two check marks?
It's a double check. You want to do a double
Yeah.
check mark or just
Yeah,
a
yeah.
second
Double
check
check
mark?
mark.
No, double check.
So 3 total?
Yeah.
Yes.
Yeah, double check.
Discount double
This might violate the rules. Hold on.
Discount double check.
Check the book.
All right, I'm going to allow it. I'm going to allow a second check.
Check prime.
Wow.
Let's not tell anybody, though. If this gets out, we could be in serious trouble.
Even more trouble than.
Can you manipulate any type of derivative again?
What's that, John?
They don't.
Okay. Casey,
Yes.
how about the derivative of that numerator?
9e to the 3x. Plus 9e to the negative 3x.
You're on a roll. Give me the denominator also.
25 cosine 5x.
Harry, pregunta? No. Sehr gut. Plug und chug.
Oh my god, we have a number.
Nice. All done. Is it possible that you could run into a problem where L'Hopital's just keeps generating 0 over 0?
Yeah.
Yes. Will you? Probably not.
Only on the HTTP.
Right.
So you could go for 2
Only
hours.
the 5 free response questions that you see on the AP involving L'Hopital's where it never ends.
You're just going for 2 hours then.
Exactly. Notice what happens with the e to the 3x. Because the derivative of e to the anything is itself, you continue to get an e to the 3x. What changes is, fortunately, the second one has a negative sign, so it flips back and forth. So, bingo, we're done. And that's our limit, 18/25.
Is there a record for what was L'Hopital's?
Not that I know of, but there might be somewhere. I just don't know what it is.
Most check marks on one page.
Exactly. Okay. Let's see. How could we make it more interesting? We did trig already. Come on, no trig.
Inverse trig.
Inverse trig, now that would be good. I didn't plan ahead for that, Sam, but that is a great idea. Thank you for the suggestion. Let's try this one. First of all, let's change the limit. We'll approach infinity. This will be good practice. Oh, yeah. Ooh, yeah.
Oh.
Things are getting ugly up in here.
It doesn't even make any sense.
Well, what I meant by that is things are getting more challenging in this classroom as we continue.
I meant the
What
problem.
didn't make any sense?
The
I thought it
problem.
was pretty explicit. Were you not prepared for the vernacular that I used?
No, I'm just confused. If infinity is not a number, how can you take the natural log or square root of it?
Don't worry about it.
Truer words were never spoken, Sam. I hate you guys. What's the natural log of infinity?
1 over infinity.
No.
Infinity.
Get out your calculators. Don't plug and chug because there's no infinity button, but graph the natural log function just as a refresher as to what that bad boy looks like.
Infinity.
Just a natural log of x. Just graph the natural log of x and see what it looks like.
Where does it approach?
Beautiful. Got it? So what is the natural log of infinity? As it keeps going to the right, it gets taller and taller. What's the square root of infinity?
Infinity.
Infinity. Oh, I smell a check mark coming. Whoosh. Changing colors. L'Hopital's applies because this is our second indeterminate form. 0 over 0 and infinity over infinity.
What are the other ones?
Oh, you'll see. Yeah, the other ones are a little more challenging.
What about infinity over 0?
Maybe.
What about negative infinity?
Christelle, could you help me out? What's the derivative of the natural log?
Sam, shouldn't you be happy?
No.
1 over x? No.
Are you asking me or telling me?
It's been a while.
I understand.
Yeah.
Just pick a side.
Would you like to phone a friend?
Stick to you, man. It's math class.
I'm thinking 1 over x, but I'm not sure.
That's what you want to go with?
Lock it in.
Yes.
Lock it in.
I'll lock
Slam
it
the
in.
metaphor.
You're locking it in.
Yes.
Okay.
Is that your final answer?
What's the derivative of the square root of x?
Yes. Oh. It's just 1/2. No.
It's a good start.
Okay.
Shh.
X is negative 1/2.
What's 1 over infinity?
0.
Zero.
0.
Negative.
0. As the denominator gets very big, the fraction gets very small. So this might be advantageous for us to simplify it first and then do the limit thing again. So we're just going to continue with this. Limit as x approaches infinity of 1 over x over 1 over 2 square root of x. We're good so far, right? 1/2 is square root, negative brings it to the bottom. You already got 1/2 there. Which is the same thing as the limit as x approaches infinity of multiplying by the reciprocal would give me 1 over x times 2 over the square root of x over 1, which is equal to the limit as x approaches infinity of 2. Well, you tell me.
Root x over x.
Which is?
X to the 1/2 power on the top, or on the bottom.
Yeah,
Top or bottom?
Bottom.
Bottom. Everybody good with that? X to the 1/2 over x to the 1, subtract the exponents, 1/2 minus 1 is negative 1/2, puts back on the bottom. As x gets very big and the numerator stays the same, what happens to the fraction? Goes to 0. How do you confirm that? Well, you can trust in L'Hopital, or if you're feeling saucy, you could graph the natural log of x over the square root of x and see what happens when it gets very big. Is that curve going up? Is it asymptotic to 0, which we would find that to be the case? How are we doing so far? Let's do one more example, if I can find my sheet. You got time, right?
2 minutes.
2 minutes? Guacamole.
I'd say no.
Wait, I have a question.
Go ahead.
So for this one, like, if you didn't simplify it and get to that, if you just plugged in 0 there, would you get 0 over 0?
Well, if you just plugged in 0 here, you'd get 1 over infinity divided by 1 over, it gets a little confusing.
So, like, if it doesn't work out nicely, then you should try to simplify it.
Correct.
Do that. Okay.
Okay, last example.
It's going ahead.
We just did this, so you should have your derivatives under control. Quick, tell me what that is, Sam. And everybody else. No, you. Put all your stuff away. It's not time to stop. No, think to yourself. Work it out in your head.
E to the x minus e to the x over 2x.
Okay?
Negative, right?
Which gives you.
Wait, the limit you want to like here?
Yeah.
Oh, 0 over 0.
Okay, then what? Do it
Yeah.
again. Do it again. Do it again. He
So-
made a mistake. What was his mistake?
You need a
I
negative.
said minus e to that.
Yeah, he did it right.
No, he said minus.
He said minus e to the negative x.
No, he
He
didn't
didn't
say
say with a smile.
Oh. Got it. Very good, Pat. That's not an indeterminate form. What happens when you plug in 0?
You get 2.
2 over 0. What's 2 over 0?
We don't know.
Yes, you do. Infinity, correct. Homework tonight or homework tomorrow.